Dear students, I have taken some more questions on special series. In this, compute the sum of the series whose nth term is given by this expression in n into n plus 1 into n plus 2 or 2n minus 1 whole square or n square plus 2 raised to power n, etc. Here already the general term, nth term is given in terms of n. So our first step to recognize the pattern is there, but we are already given the general term. We'll write that. We'll apply the operator sigma on both sides and then use the special series formula. Let me take the first one, solution. That we are given here an or tn, whatever you want to write this as this much. Now, to apply sigma operator, we first will have to simplify it like this. This becomes n cube plus 3n square plus 2n. And now we have studied the properties on sigma operator. The sigma an is, you can write it as Sn, and so sigma over all the terms. And applying the properties here, this can be written sigma n cube plus 3 times sigma n square plus 2 times sigma n. The constant can be taken out of the sigma sign because it is on k. Actually, this is sigma k cube, k running from 1 to n, and then 3 times sigma k square, k running from 1 to n, plus 2 times sigma k, k running from 1 to n. But this we can also write in simplified manner as this, because it is very clear that n is starting from 1 to n. So we can have the formula direct as this upon 2 whole square plus 3 times n plus 1 into 2n plus 1 by 6 plus 2 times n plus 1 by 2. We have applied all the formulas for sigma n cube, sigma n square and sigma n. Now we are just to simplify this expression, otherwise this is our sum. So let me take whatever the common there, I will write it. This whole term is taking, I have taken common. So after that, this is n into n plus 1 by 2 plus, this is common, 2n plus 1. This is also common, plus 2 we are left with. Now we are having n plus 1 by 2, and this is your n square plus n plus 4n plus 6 by 2. I have taken the LCM. And so this is n into n plus 1 into n square plus 5n plus 6 upon 2. And so we are having n into n plus 1. By splitting the middle term, this can be written as n plus 2 into n plus 3 by 2. So we have seen that if the nth term is given by this, then for that series, the sum of the formula Sn will become this much. Let us take the second one. That is your 2n minus 1 whole square. Now in this we are given the whole square. So we have to simplify it first and then apply again the sigma like we have done in previous. So this is 4n square minus 4n plus 1. We have opened the square, whole square, and if I write sigma an, this is 4 times sigma, I may write first of all sigma over 4n square minus 4n plus 1, that means sigma 4n square minus 4 sigma n plus sigma 1. This 4 can also be taken outside. Now, we have seen that sigma n square formula there, sigma n, and we have studied one more property for sigma a. When k is running from 1 to n, this is n times a. So, I will be using these all formulas here. This is 4 into n plus 1 into 2n plus 1 by 6 minus 4 times n into n plus 1 by 2, and this is n. So we have used all the formulas. You will write on the side the formulas, and again if there is something common you can take that. This is your n common first of all, and we are left with 4 times this n plus 1 into 2n plus 1 minus n plus 1 and plus 1. So we are left with this as 3 minus, taking LCM, this is your 2 into 2n square plus 2n plus n, 3n plus 1 minus 3n minus minus 2 times, so this is minus 6n minus 2, 6 plus 3. So we are left with upon 3, that is yours 4n square plus 6n plus 2 minus 6n minus 3 into n divided by 3, that we are left with 4n square minus 1 into n by 3. We can further, if we want, make the factors like this upon 3. And the last one we will be taking as a and as n square plus 2 to the power n. Now you can see the first, this is broken into two parts. This n square, if I apply sigma operator, this Sn will become sigma over n square plus 2 to the power n. Now this is sigma n square separate plus sigma 2 to the power n. That if I want to clarify, I may write this in k terms so that it is clear. K is running from 1 to n, this is 2 to the power k. Now you can see we have special series formula directly here, n into n plus 1 into 2n plus 1 by 6. And we have, this is the GP with first term a as 2 to the power 1, and common ratio r is also to the power 1 to the power 2, so this is 2, and we can apply the formula for Sn as a into r to the power n minus 1 upon r minus 1. So what we will get here, 2 into 2 to the power n minus 1, there are n terms upon 2 minus 1. So we are getting it as n into n plus 1 into 2n plus 1 upon 6 plus 2 times 2 raised to power n minus 1, or we can write it as 2 raised to power n plus 1 minus 2 if we want, and this will be your answer.